So in this problem, Edward is making a rectangular picture frame, and he wants the perimeter. Let me make a little rectangular perimeter frame. He wants the perimeter of the frame to be no more than 96 inches. He also wants, so I can't help it, but when you see something like no more than 96 inches, that means it can be 96. So we're talking about something that's less than or equal to 96. He also wants the length of this thing to be 4 inches less than the width. So if we were to call this the width, then the length would be the width minus 4. Okay. Create a system of inequalities. Wait. He also wants the length of this to be greater than or equal to the square of 4 inches less than its width. Let me reread this. He says he also wants the length of the frame to be greater than or equal to. Okay, so we need to do this. He wants the length to be greater than or equal to the square of 4 inches. So I think they mean this, the square of 4 inches less than its width. Okay. Create a system of inequalities to model the above situation. Use it to determine how many solutions are viable. So we're talking about a perimeter, and the only thing they give us is that, well, the perimeter would be, we're going to have 2L plus 2 times W equals the perimeter. But we know that the perimeter has to be less than or equal to 96. We know that it would be 2 times W minus 4 squared plus 2W. But remember that this has to be greater than or equal to. So that comes into effect, but it doesn't really. We could treat this as an equal to with the assumption that it could be less than. In other words, it's never going to be, well, there's a contradiction. It's a system of equalities where there's two equations, all right? So if we were to go through and do this whole problem, which we don't really necessarily have to do, because I can tell you by doing the math on this, we're going to find out that some of these solutions are going to be negative, okay? And those are not viable. So what does that mean? That means that we cannot have a negative length or width for that matter, right? So if we go through and we crank through and we do all the math, that's a parabolic shape, right? It's going to look like this. And it's going to cross the axis in the positive direction and also in the negative direction. And so the negative number we can't use. So I think it is B, because part of the solution region would have a negative width. Therefore, not all the solutions are viable for the given equation. So there's going to be two solutions. Well, actually, because of the inequalities, there's going to be multiple solutions. So what we would do is we would graph this equation. Then we crank through the math and do this equation and graph this. And what works is where the two overlap. But I know by looking at the length equation, some of these are going to be negative, right? So let me show you what I mean by that. So if I graph So when I go to graph this, let me clear this out. If I say the quantity x minus 4 squared, right? And then down here I say 2 times, is it x minus 4? Yeah, x minus 4 squared plus 2 times x, and then minus 96 because we have to set it equal to 0. Okay. And then I got one of these, so this one has to be less than, so we're going to shade below. So we're going to do this, shade below. And then this one has to be greater than this value, so we would shade above. Oops, that's it right there. And then zoom would be, I don't know, we'll do zoom fit, which is 0. So where the two overlap are are possible solutions, right? So let me zoom out a little bit because let me do a standard zoom. And I'll probably have to zoom out a little bit. So what we're looking at is where the two overlap. Now it doesn't look like they overlap here, but if I zoom out, if I change the window from negative 100 to 100, and my y goes from negative 100 to 100, and so what you'll see here is the solutions are where the two overlap. So over here, it overlaps in the negative, and over here, it overlaps in the positive. The viable solutions are just the positive ones. The negative ones won't work. These are values of w, which I called x in the calculator. That would be negative. So that would mean that we would have a negative width. You can't have a negative width. Over here, though, are going to be positive values. So when we talk about a measurement of width, we'd want positive values. So that's why, let me take a screenshot of that so it makes sense. That's why it's not a viable solution, because you can't have negative widths. So let's just note that for future reference. So right here, this region right here, these are mathematical solutions. But you can't have a negative width. And where it overlaps over here, these are the viable solutions because they're positive. Now that's just in a box. Like sometimes if you were to do this sort of math for like an electronic thing or a physics problem, you can have negative solutions. But in this particular case, you would never have a negative width. Okay?